Hi, welcome to BC Video 9.98 Part 2 Extra on creating a series from another series. Okay, number 6, looking at the worksheet, number 6, which is this one here. It says use a substitution and then followed by a multiplication or division by a constant. Now this is a little trickier because this is 1 and this is 3, so that's where we're going to multiply by 3 at one point. But notice this is 1 minus x and this is x minus 2. So what I'm going to do is the following. This is a little trickier, okay? What we're going to do is we need we need to start just by replacing x by something. By replacing x by x over 2, okay, I will then have 1 over 1 minus x over 2. If I then multiply that expression by negative, the whole thing, by negative 3 halves, I'll have 3 times 1 is 3, so there's the 3 that I needed. And then when I multiply the denominator by negative 2, I'll get negative 2 plus x, which is, of course, the x minus 2 that I'm looking for. Okay? So the first thing I did is replace x by x over 2. So I have to replace this x by x over 2. I do it with all of these, including the interval. And then I realize that this is x to the n over 2 to the n. And then I realize after checking the first term, this has to start at 0. Then I multiply everything through by negative 3 halves. So here I can just put the negative 3 halves on the outside for now. Here I put it on the outside. I'm multiplying the entire infinite polynomial by negative 3 halves. So this is just the distributive property since that's just a monomial. And here I can bring the negative 3 in. That's 2 times 2 to the n, which is 2 to the n plus 1. And then you figure out your limit of integration. And again here, I replace x by x over 2, multiply by negative 3 halves, etc. For number 10, it tells you differentiate the original series and then divide by a constant. Differentiate number 9, so you're taking the derivative twice. Okay, so here's what happens. We have 1 over 1 minus x, which, by the way, is 1 minus x to the negative 1. If you take the derivative of that, you'll get negative times 1 minus x to the negative 2 times negative 1 by the chain rule, which actually gives 1 over 1 minus x squared. If I take that expression over here and take the derivative of that expression, I'll get negative 2 times 1 minus x to the negative 3, again chain rule, times negative 1, which gives me 2 over 1 minus x cubed. Okay? And what I want is 1 over 1 minus x cubed. So all I'll have to do after I get to this point is simply divide through by 2 or multiply through by half. Okay, so there's our original geometric power series, 1 over 1 minus x, x to the n. So I'm going to first take the derivative of that. So to get from here to here, I'm differentiating. So the derivative of 1 over 1 minus x, as we showed, is 1 over 1 minus x squared. I'm going to take the derivative of this, which is going to be n times x to the n minus 1. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x, etc. So there's the first few terms. And then by observation, you'll figure out that it has to start at 1. Then I'm going to take the derivative again. We showed that that was going to give this expression. So that's just a constant. Then I'm taking the derivative of x to the n minus 1, which is n minus 1 times x to the n minus 2. The derivative of 1 is 0. The derivative of 2x is 2. The derivative of 3x squared is 6x. By observation, you'll figure out that has to be 2. And then I'm going to divide through by 2, or if you wish, multiply by a half. So that'll give me 1 over 1 minus x all cubed, which is what I wanted. Here I'm just going to write over 2, and here I'll divide by 2, etc. And then again, you carry all those operations through on the interval of convergence. The power series for e to the x, we started with that a long time ago, but if you did the table, all the derivatives of e to the x are e to the x, and if you're doing a Maclaurin's, e to the 0 is 1. So this is another series that you should just know. E to the x is 1 plus x squared over 2 factorial plus x squared cubed over 3 factorial, and that interval is convergence is all real numbers. So you should just know this series now. X to the n over n factorial is e to the x. If you wanted to find the power series for ln x near 1, for example, so that's a real Taylor series. So the derivative of ln x is 1 over x, which is x to the negative 1. The derivative of that is negative x to the negative 2, etc., etc. Okay. And then you're evaluating that at 1. So ln of 1 is 0, 1 over 1, negative 1 over 1 squared, etc. And don't forget that this is the numerators of your coefficients. Don't forget it is near 1, so it'll all be x minus 1 to the 0, x minus 1 to the 1, x minus 1 to the 2, etc., etc. And then, 0 factorial, 1 factorial, 2 factorial, 3 factorial. So that's one way of getting the series. Another way of getting the series is to start with g of x equals 1 over x, which you would need to find that series near 1. And then once you have that series, you would be able to integrate, because of course the integral of 1 over x dx is ln x, and you would see that you would get the exact same thing. It doesn't look right now like it's the same thing, but it is the same thing, trust me, okay? Yeah, yeah. Uh, Actually, I'm going to erase. Let me stop that for a second. Okay, sorry about that. So yes, if you integrated x minus 1, you get x minus 1 squared over 2. Let me take, well, it doesn't really matter, but it's over 2, which is the same thing as 2 factorial. And then if you integrated this would be a constant you pull out, and then you'd integrate x minus 1 squared to get x minus 1 cubed over 3, which, by the way, 3 times 2 factorial is 3 factorial. So it all works out to be the same thing. If you wanted to get a series for the inverse tan of x, all you'd have to do is integrate 1 over 1 plus x squared dx. And how would you get 1 over 1 plus x squared? You could start with our famous 1 over 1 minus x and replace x by negative x squared. Okay? So here's the process of doing that. You start with 1 over 1 minus x, replace x by negative x squared, integrate, and you'll get a series